they're on there too.
Okay. I'm not sure, but it's not letting me.
Oh, my bad.
screen share.
Yeah. Give me a sec. There, yeah, try now. All right. Okay. All right. Let's
It
take.
kind of got cut off, but
Okay. All right. The lines graphed in the XY plane above represent a system of linear equations. What's the solution to the equation? Okay, so what's that? The solution is just where the two lines intersect.
yeah, that would be 2, 3.
1, 2, yes, yep.
So that would just be
yeah, C.
C.
Yep. 3. Rosa has already eaten 10 pretzels from a bag that originally contained P pretzels. If Rosa is able to eat each remaining pretzel in 18 seconds, which of the following represents the amount of additional time in seconds needed for Rosa to eat all pretzels in the bag? So she's already eaten 10. If Rosa is able to eat each remaining pretzels in 18 seconds, which of the following represents the amount of time, additional time in seconds needed for Rosa to eat all the pretzels? Okay. The bag originally contained P pretzels. Okay. Which of the following represents the amount of additional time? Okay. P was able to eat each remaining pretzels in 18 seconds. So there's P total. There's P total pretzels. She's eaten 10 already. 10 already. Is Rosa's able to eat each remaining pretzel in 18 seconds? So 18 seconds to eat one. 18 seconds to eat one. Eat one. Which of the following represents the amount of additional time in seconds needed for Rosa to eat all the pretzels in the bag? Okay, so there's how many left? There's P minus 10 left, right?
Mm-hmm.
So there's P minus 10 left. And then she's eating 18 per second.
So that would be
D. Times, yeah, the 18 seconds. Yep. So that, I'm thinking D. Yeah.
Okay.
Yes. Well, okay. So A, what about A? A, why does the A, B, C make sense? Which of the following represents the amount of additional time? All the pretzel. Okay, yeah. Yep. It wouldn't be 10 minus, it wouldn't be C, 10 minus P.
because it's P minus 10.
Yeah, P would be the totals. Yeah. It's not B because
It's multiplying by the amount of pretzels that she already ate.
yeah, right. And then A, it's not A because 18 seconds minus, that would mean 18 seconds minus the total pretzels. That doesn't make sense.
Mhm.
All right. What's the next? 4? All right, 4. What are the y-intercept and the slope of the line defined by the equation? That. Okay, so how do we do these types?
We would solve for y.
Yes, for the y-intercept, you'd let x equals 0 and solve for y. So if x is 0 here, we have 0 equals 7y plus 9. The middle term cancels out if x is 0.
Mm-hmm. So then you would get
7y equals negative 9. Y, that means y is negative 9 over 7. That's the y-intercept. And what else do they want? They want what are the
slope.
And the slope. Okay, so for the slope, just put it in y equals mx plus b form. So 0 equals 7y minus 5x plus 9. Just solve that for y.
So we get
It's either A or C.
you would get 5/7x.
Negative 5 over 7.
Yeah, negative 5/7. So
Negative 5 over 7 and negative, so that's A. A, yep. All right. 3 or 5. If, what does that say?
that's okay.
5 divided by m? M?
We can skip that one and move on to 7.
All right, what complex number is equivalent to the equation above if I equals root of 1? Okay, so for this one, just collect like terms.
Okay.
4 minus 6 is negative 2. Looks like this. 4 minus 6 negative 2. 7i minus 2i is
5i.
5i. Yeah, C.
So C.
Yep. 6. If no, it was a line P not shown is perpendicular to line Q, which is shown above, and passes through the point 0, 4. Where's 0, 4? 0, 4 is right here. Which of the following equations could represent line P? Okay, so we know we can find the equation of line Q. What's the equation of line Q? What's the point right here? What is this? Negative 4 right here? So something minus 4. Y equals something x minus 4, right? What now? What's the slope? From that point to say this point? What's the slope?
It's up 4/3. So
Up 4/3. There's your Q line, right? So now we know P is perpendicular to that. So what would the slope on that one be?
y equals -3/4.
Yep, -3/4. And then they say it goes through this point. Plus x plus 4. Right, it goes through this point. So it's something like that, and that's 90, and that's 90. Like that.
So would it be B?
Yes, yep.
Okay. Oh, we already did that one.
All right. All right, which one are we on?
8.
8. Given the equation above, what is the value of n? So just cross multiply on this one. Yep. It's 8, yep. I just saw for n there. Yep. There's 21. No, what is that? 20. Oh, that's that's 15. Yeah, that's right. 23, yep. What is the solution set to the equation? That, okay, so that means just solve for A. Just expand it out and solve for A.
Okay, so
Actually, you don't need to expand it out. If it's 0, then we know that 3A plus 1 equals 0, or A equals 4. What's this one solve for A? This one would be 3A equals -1, A equals -1/3.
and it's squared.
So this, yeah, so there'd be 2 of these, right? This one would be 2 of those. Which one is that? Actually, let me think about that. If you take, there's 2 of them, right? Actually, no, it would just be 1 of them. negative 1/3 and 4, which is B. Yep.
Okay.
Which one? 11. If 3 is a root of the function that and C is a constant, what is the value of C? So if 3 is a root, that means that just you can plug the 3 in for X. Plug the 3 in for X and just solve for C.
Oh, okay. So 3 squared plus 13 times 3
Yep. Plus
plus
C.
C.
Yep. And this is if 3 is a root, and this is Y equals this stuff. Y equals
Okay. And 13 times 3 is
39. 39 plus 39 plus 9. Yep.
48.
Okay, so let's see here. If 3 is, oh, my bad. This would be 0. Yeah, this would be 0. Sorry, not this should Y. That would be 0. If it's a root, that means that's one of the zeros.
So that would be the answer.
Yes. Exactly. Yep. Negative 48. Yep. That works. Yeah. A. What's that? 12 or 11? What is the solution set to the equation that what would the common, just change everything to the common denominator? The common denominator will be m times 7 minus m. What is the solution set to the equation that? Or, yeah, you'd have to write all three terms under all three terms over this common denominator. So you could say 2 over 7 minus m equals, oh no, this would be 2m times m here, right? That's the first one. Second one would be 4 7 minus m over m 7 minus m.
Mm-hmm.
Hold on one second. Hold on one second.
Okay.
Let me mute this. Okay, all right. Okay, so yeah, change everything to the common denominator. Okay, the first one is done, second one's done, minus
This one should be, would it be 5
m.
minus m times m?
Yeah, and then over the same denominator. Yep. Okay, so now if we clean up the left, if we clean up the right side, what do we get? We get what is the solution set? Actually, we could have done it this way. What is the solution? What's, maybe this might not be the fastest way. Is this the fastest way? We could do it. see how you have two answers and then the last one you have one answer? Why would
Yeah.
we get two answers? How would we wouldn't get two answers, right?
I don't think so.
No. So if we just take this 4 on D and plug it into the original, would we get what's 7 minus 4? 7 minus 4 is 3, right?
Yeah.
So the left side would be 2 over 3. What would the right side be? 4 over 4 would be 1 minus 1 over 3. Yeah, exactly. 4.
Okay.
Yep. Some of these you don't need to do all the intermediate, all the steps, right? Just look at it and see the best answer. 12, the above expression is equivalent to which of the following expressions for all b positive, for all b greater than 0? The above expression is equivalent to which of the following expressions for all b greater than 0? Okay, so for this one, just change it over, the same thing, common denominator. What's a common denominator? Common denominator.
Would it just
12b3 would be the common denominator, right? So the first
Okay.
one leave alone, leave the first one alone, 12b3. Second one would be minus 9 over 12b3, right? Okay, so can we reduce that? That would be what? Negative 2 over 12b3, which is negative 1 over 6b3. Do we have that?
Yeah. A.
Yeah, first one.
Okay.
System equation shown, graphed in that. The system has if the system has two solutions, what is the product of the x coordinates of the two solutions? The system equation shown above is graphed in the xy plane. If the system has two solutions. Okay, so if it has two solutions, this one's a straight line and this one's a parabola.
Mhm.
Okay, so if the system has two solutions, what is the product of the x coordinates of the two solutions? Okay, how can we do this?
You could set them equal to each other.
Yeah, that's what I was thinking. X2 plus 3 equals 15x minus 33. What do we get there? X2 minus 15x. What's right here? 3 plus 33 is 36, right? 36.
Mhm.
Can we break that down? Two numbers that multiply to 36 and add to negative 15. 18 and 3?
Yeah.
Negative 18 and 3. X squared minus 18x plus 3x plus 36. 0. Factor these two, we take an x out. What do we get? We get x minus 18. Factor these two, we take out a 3. What do we get? We should get the same thing. X plus 12. No, wait, what did I do wrong there?
That would be
Let's take
18.
out a 3x. Take out a 3x. That's what it is.
Yeah.
Take out a 3x. Take out a 3x, and we have x plus. Well, we should get the same brackets, though. How come I'm not getting the same brackets?
Um.
18x plus 3x, that's negative 15x. Uh, Oh, yeah, actually, no, you can't take out a x 3x here. You could just take out a 3. If you take out a 3, it'll be x plus 12. So if I just take out the 3, 3x plus 36. But that doesn't, this and this doesn't match up.
No.
System of equations shown in a graph in the XY. If the system has two solutions, what is the product? Okay, first we just got to find the solutions. Okay, we just make a quick sketch. What does the first one look like?
It would look like up here.
Right, and this point is 3, right? This point right here
Yeah.
is 3. Now, what does the second one look like? Negative 33 is down here somewhere. There's your y-intercept of negative 33. Negative 33. We go up 15 to negative 18, which is right here somewhere, negative 18. There's our first point. Second point, we go up 15 and 1 to the right, which is there. And then we draw that line. Something like that. I drew it wrong. Undo that. Undo. Can I undo? Redo. So it connects these 2 points. And then extend it like that. So really, it should intersect the blue twice. There's once. And where would the other one be? All right, let's try to draw it like this. System of equations shown above is graphed in the XY plane. If the system has two solutions, what is the product of the x coordinates of the two solutions? Okay. What do we do wrong there? X squared plus 3 equals 15x minus 3. X squared minus 15x plus 33 plus 36 plus 36 plus 0. Two numbers that multiplied 36. They multiply to 36 and add to negative 15. I think I picked the wrong two numbers before. What are multiples of 36 that add to negative 15? Multiples of 34. Say it again.
12 and 3.
There you go. There you go. I picked the two wrong numbers. Yeah, there you go. Negative, each of them are negative. Yeah, wrong two numbers. Negative 12x minus 3x plus 36. Yeah, that works. There you go. All right, so factor these two, take out your x. You have x minus 12. There you go. And minus 3 here. X minus 12, 0. From the first one, you'll get x minus 3, and x minus 12. X minus 12. Okay, so from this one, you'll get 12 from this one, and you got 3 from this one, right?
Yeah.
Okay, so this one is 3, 0. And this one is 12, 0. Multiply the two x values, 36.
Okay.
3, 0. Well, my graph is way off, right? This is just a rough sketch. The 3, 0 would have been, well, 3, 0 is right here somewhere, right? Three, 0, and then 12, 0, somewhere right here. Do we have the answers on this?
I think the answers are on here.
Is it 36?
What question was that?
Keep going down.
I think this is at 13. The answer is A.
Yeah, that's what we had. 3 times 12. Yep. All right, I just picked the wrong numbers in the factoring.
Okay.
Okay, for all values of A, which of the following is equivalent to the above? Okay, so just apply your exponent laws. So the
Mhm.
the 3/5 go to both terms. -27 to the 3/5 and A to the what is this? 10 times what's 60% of 10? That's just 6, right?
Mhm.
30 over 5 is 6, right? So now just simplify this a little bit more. Um, what's this part right here? What's -27 to the 3 over 5? -27. Oop, I meant root 27, -27. Where does the 3 go? Where does the 5 go?
The 3 goes here, and then the 5 goes here.
The 3 goes right here on the outside.
Oh, okay.
And then okay, so A6. Yeah, okay, so now can we simplify this? Do we have a number? Is this any one of the answers? No. Okay, can we simplify? How can we simplify that further? Can we simplify this first term anymore?
Um,
Is there a number times itself 5 times that's -27?
I don't think so.
-3, no. -3, -3, that's -27 right there.
Mhm.
But that's 3 of them, not 5 of them. Did I do that right? No, I did it wrong. No, I did it wrong. The 3/5 should be, it should be like this. It should be 27 to the 3 over 5. Negative, yeah, yes. We should be doing the exponents first, not the. All right, let me erase this line. We should be doing the exponents first. So it should be like this. It should be 27 to the 3 over 5, negative on the front, and A6. Okay, so what is 27? If the 5 goes here, well, it's the same thing, similar, and 3 goes there, A6. Can we simplify that? Oh, yeah, we can break the 27 down. We can break the 27 down. Break it down like this.
3
fifth-
times 9?
Can we break it to 9 and 3?
Yeah.
How would we write it? How would we write that? Fifth root of 9. Is this right? To the 3 like that? No. No, that doesn't make sense. If we break down the 3, let's break the 27 down into 3. Yeah, let's do that. Do it like this. Break it down into, that stays negative there. If we break it into this, do it like that. There's your 27, right?
Mhm.
Now there's your 3 over 5. Yeah, just rewrite it like that.
Okay.
So now leave the negative on the front and then multiply these two. Multiply the 3 and the 3/5. What is that? 9 over 5.
9
So
over 5.
like that, 3 to the 9 over 5, A6. Can we simplify that? What would that equal? That would equal negative on the front, root 3, 5 there, 9 there, A6. Is that one of them? A6. Um, okay, so this first one, we've got the A6. We've got 5 root 3 times 3. So we can write it like that. 3/5 root of root 3. Is that the same as this? As this? Uh, 9/5. What about the last one? A5. A5, A5, A6 and B, and A6 and A. All right, let's check that one. Let's check the answer on that one. Let's see what they did.
That's number 14.
Yeah.
They got B.
Okay, so we know how to get the A6. What did they do with the rest of it? What did they do with the? Oh, okay. Answer is B. Raising 27 to an exponent is difficult on the no calculator section. To start with A. So start with A. Raise A to the 10. Okay, that's okay. We get A6. Eliminate C and D, which doesn't include A6. Now work with the coefficients. The expression with the fractional exponent is equivalent to a radical expression with the numerator and of the exponent becoming the new exponent and the denominator exponent become an index. That just means the bottom becomes the number on the inside, the top becomes the number on the outside.
Mhm.
For the coefficient on the -12 to the 3rd power. Then taking the 5th root of that. Calculator is not allowed here, and doing this work without 1 is tricky. Okay, they just kind of did it by elimination, eliminating the 2's that don't have A to the 5 or A to the 6.
Yeah. Okay.
And then they just simplified it. 15. Amount of carbon 15 in a given sample decays exponentially with time. If the function that models the amount of carbon 15 remaining in the sample after m minutes, which of the following must be true? Amount of carbon in the sample halves every minute. Amount of carbon in the sample halves every 24 minutes. Amount of carbon in the sample halves 24 times every minute. Amount of carbon in the sample reduces by a factor of 24 every 2 minutes. After m minutes, which of the following must be true? Okay, so let's just plug in a few of the first ones. After 0 minutes, C0 would be M. This would be 0. Anything raised to 0 will be 1. So this would be 100.
Yeah.
100. C1 would be 100. The fraction part would be what? Half raised to the 24. If m is 1, if this is 1, that's 24. What is this? 100 half raised to the 24. If what's C2? C2 is what? 100 half to the 48. And then let's do one more. C3 would be 100 half 72. 24 times 3 is 72. Okay, so it's getting way smaller each time, right? So the amount of carbon in the sample halves every minute. Is that true?
No.
Amount of carbon in the sample has every 24 minutes. Halves every 24 minutes. Okay, so you have 24 here, then you've got another two 24s, then you've got three 24s. So that one seems about right. I think this one's right. The amount of carbon in the sample has 24 times every minute. Has, and what's C or what's M? M is M is minutes. Amount of carbon in the sample has 24 times every minute. Has, what's the last one? Amount of carbon in the sample reduces by a factor of 24 every 2 minutes. Amount of carbon in the sample reduces by a factor of 24. No, I don't think it's this one. I don't think it's this one. I think it's this one. Amount of carbon in the sample has 24 times every minute. I think it's B. Let's check that one. 15B.
If it was B, but I thought M stand for minutes, so wouldn't 24 not be the minutes?
M does stand for minutes. M after M. So say it again.
So like how would it, the 24 wouldn't mean minutes because the M stands for minutes.
Yes. The amount of carbon in the sample has every 24 minutes. That's B. C, the amount of carbon in the sample has 24 times. So then what you're saying, C?
Yeah.
All right, let's check that one. 15C. Oh yeah, 15C, yeah. All right, so that one's just like just understand what's going on. 16, if 0 equals that, what is the value of n? This one, common denominator.
Okay. So
Multiply the first one, multiply the top and bottom of the first one by n plus 1. Yep. And then the second one, top and bottom by n minus 2. Yep. And then the next line would be simplify the numerator on the next line. Foil out the top. Yep. 2n plus 2 minus 6n plus 2.
minus 12.
Yeah, sorry, my bad. Yeah. Plus 12, plus 12. 2n plus 2, yep. Minus 6n plus 12, yep. All right, now just simplify the top there. 2n minus 6n is negative 4n. 2 plus 12 is 14.
Would it be 2 minus 12?
This negative and this negative would give you positive, right? This positive.
Mm-hmm.
So 2 plus 12 is 14, isn't it?
Okay.
2 plus 12, 14. So negative 4n plus 14 over the same denominator. And then now on the top, factor out, can you factor out a 2 on the top?
So you'd get a negative 2 or a positive 2?
Factor out a -2, so that'll be 2n plus 7. That's as far as you can go, right? This will be minus here, right? -4n plus 14. Yeah, I think that's as far as you can go. What is it? Okay, well, how else could we do that? Did we do that right? We multiply the first one top and bottom by n plus 1. We multiply the top and bottom of the second y by n minus 2. 2n plus 2 minus 6n plus 12. Yeah, that looks right. Oh, if we were to, no. Can we do anything else? Let's check that one. Check that one, 16.
They got
Okay, so
14
they
over
got a whole
4.
number. Okay, they got, all right. All right, they did it. Go scroll back up. All right, so for that one, they didn't do it with the common denominator method. They did it by, if that minus that is, oh, my bad. Look, if this is 0, then this and this have to be equal to each other, just like 5 minus 5 is 0. So that means that
Oh,
equate them to each other
okay.
instead of all that work. My bad. 2 over n minus 2 equals, so just cross multiply there and solve for n. Yeah, my bad.
And you'd get 2 n plus 2 equals 6 n minus 12.
Yeah, if you go through the steps there, you should get that 14 over 2. Yeah, there you go.
Yeah.
Or 14 over, what was it, 3.5? My bad. 7 over 2 is 3.5. Yep. All right. 17 or 18. An angle in the XY plane has a measure of 5 radians. What is the measure in degrees? So just use the ratio. We know that 180 degrees equals pi radians. Just equate this to an angle in the XY plane. What is the measure of the angle? So this would be x degrees over 5 pi radians. And just cross multiply them.
180 over 5 pi.
Yes, which would be what, 16? If you multiply, you go pi x here equals 5 pi times 180. Divide both sides by the pi's will cancel out. Or did I do that right? Did I do that wrong? Pi x equals 180 times 5. 36?
Mhm.
All right, that one works. All right, that's 18. What did you get?
I got 36.
No, it can't be that small. Remember, we know that 2 pi radians is 360, right?
Mm-hmm.
Or we just do like this. How do you go from, oh no, let me write this. 5 pi radians. We're looking for the degrees, right? X degrees here, right? How do we go from 2 to 5? What do we multiply by?
1.5.
2.5.
2.5, yeah.
Times 2.5. So same thing here. Take that and multiply it by 2.5, and you should get the x there.
Oh, okay. So it'd be
360 times 2 is 720 plus 180. What is that? 900?
yeah, 900.
900. Okay, yeah. It can't, 36 degrees is too little, right? Remember, here's your XY, right? That's 360. That's one revolution. That's two pi revolutions. Then another 2 pi, which is 720, and then another half.
Okay.
I think it's about 900. All right, that's 18.
17.
17. In the figure above, triangle XYZ is a right triangle with XZ equals 3. If 10M equals root 3, what is XY? Okay, so right triangle X, okay, the bottom is 3. If 10M, so we know that 10 theta equals what? Opposite over adjacent, right? Opposite adjacent. That's an A, that's an O. So then plug this in. 10M is root 3, right? Root 3 over 1. Where's your M? So we're talking about this angle right here, right?
Yeah.
Opposite would be root 3 and adjacent. Did I do that right? 10.
Well, adjacent is 3.
Adjacent is 3, right? What is XY? We're trying to find. We're trying to find this distance right here, the hypotenuse.
Okay.
So how do we find the hypotenuse? Figure above, triangle XYZ is a right triangle with XZ is 3. XZ is 3. If tan M opposite over adjacent, tan M equals opposite, which is this, over adjacent, which is 3. What is XY? What is the hypotenuse? If we have so this is the adjacent, right? This is the adjacent, and this is the opposite side in relation to angle M. So if we have, so then if we say cosine M, cos M equals adjacent over hypotenuse. Do we know what this is? Cos M adjacent is the 3. How can we do this? Cos M would be adjacent over hypotenuse. Or is it sine? Sine will be opposite over hypotenuse. If we use this one that they give us, which is this one.
Would YZ be radical? Would YZ be 3? I mean, rad 3?
Yeah. Yep. So this is rad 3, this is 3. Okay, so then we could just take the what do you call it? The Pythagorean.
Mm-hmm.
If we square both of them, if tan M is opposite over adjacent, but adjacent is 3, not 1.
Yeah.
That's what's tripping me up. So what am I doing?
Should you set it up like a portion? Like we know it's supposed to be 3 over 1, and then we know the adjacent's 3, and we don't know that.
But we're trying to find this distance here though, right?
Mm-hmm.
So how would that help us there?
Because then this would be the opposite. That would be the opposite. And then we'd have the adjacent. So then we do 3 rad 3 squared plus 3 squared equals xy.
Okay, I'm with, I see this line. This line makes sense to me. Explain this line to me.
Well, we know that tan m is radical 3, so that'd be radical 3 over 1.
Yep.
And then it would be opposite over adjacent. And we don't know the opposite yet, but we do know the adjacent is 3. So we just cross multiply.
Isn't the opposite root 3?
No, that would be tangent. This over this would be root 3.
Yes, okay.
But we don't know what the opposite is. We know the adjacent is 3.
All right, if you squared this out, what do we get? We get 9. What is this? 9. What's this one? This one is 9 times 3, 27 plus 9 is xy, which is 30. Oh, this squared, right? This is squared. This is squared here, which is 36. So you're saying this, so you're saying xy would be 6.
Yeah.
All right, check that. Let's check that one.
Okay. That's 17.
Yes, you're right. Yeah. Okay. Yeah. What you said is summed up right here. What you're saying to me a minute ago was this, right?
I think so.
Yes. Yeah. Yeah. That would be the opposite. Yes, exactly. You're exactly right. Yep. Good. Okay. Which one are we on? 19. Robert is selling televisions at the electronics store. The televisions normally cost $5.45 each, but are being sold at an 8% discount. What is the minimum number of televisions Robert must sell if he wants to meet his quota of 100,000 in total sales? Okay, so 545, 8% discount. What is the minimum number of TVs Robert must sell if he wants to meet his 100,000? Okay, so if it's 545, the original price, what's the sales price? What's 545 times 8%? What is that?
That would be
43.6. So that's so the price would be
501.4.
501. That's 545 minus 43,
43.
right?
Yeah.
43.6. So what was it? 501.4?
Yeah.
All right, so the new price is 501.4. Take that 501.4. How many times does it go into that 100,000? That should be your answer. What is the minimum number of TVs he must sell? So just take your 100,000 and divide it by 100,000 divided by 501.4.
That would be almost 200. It would be like 199.4.
About 199. So all right, let's check that one.
That's 19.
Yeah, 19. Oh, minimum. Okay. Okay, so they round up to 200 because if it was 199, okay, so 199, if we take the 199 and we multiply by 501.4, is that 100,000? No, it's a little bit less than 100,000. So you round this up to 200
Okay.
because it has to be at least, I think they said at least, right? Yeah, yeah, right here. There's your at least right there. That's why.
Okay.
Okay, a linear function is graphed in the xy plane. If g of -3 is 4 and g of 2 is 19, what is the slope? Graphed in the xy plane. If g of -3, okay, so here's your xy. G of -3, here's your -3, and your 2 is right here. -3 would be 4. This is 4. That right there. And g of 2 is 19, which is up here. 19. Yeah, exactly. Just there you go.
So then we just do the formula.
Yeah, y2 minus y1 over x2 minus x1. (15 over 5, which is 3, right?
Mhm.
All right, that one's good. All right, try one more.
I think that's the
Oh,
last
that-
question on it.
All right. Oh yeah, 3. All right.
Oops. Was there one? Is this one that we skipped?
Okay. Which of the following expressions is equivalent to the expression above? Just collect your like terms. 3x4, is that 4? Is that first one 4 or 6?
I think that's 3x4. Yeah.
4. Okay, so 3x4 would be by itself. Where's the 3x4 would there's no like term like that one. 2x3 minus 5x3 would be -3x3. -7 plus 9, which is 2. What's that one? Is that 4x6?
Yeah, 4x6.
All right, so that one's a like term. 4x6 plus 3x4 minus 3x3 plus 2. Do we have that one?
Can you repeat that?
It would be 4x6 plus 3x4 minus 3x3 plus 2. We have that? Which one is
I
that?
think that is.
I can't really tell what A and B, like the first term on A, B, and C are.
Oh, for
That-
A is read 4x6 plus 3x4 minus 3x2 plus 2. So, yeah, A.
Okay. All right. Yeah. That one you just click like terms. Yep. All right. Anything else?
I don't think so.
Good. You good for today?
Yep.
All right. I'll meet you again next week. All right. I'll see you, Brianna. All right. Just keep practicing. You're doing right. Just keep putting the work in every day.
Okay, thank you.
Okay. All right, Brianna. See you.
Bye. Have a good weekend.
You too. Bye.